Welcome to cryptography session. Today I give an introduction about RSA algorithm. So in public key applications, there are three categories are available. Using the public key, we can able to do encryption and decryption process. For that application, we are normally using an algorithm called RSA algorithm and elliptic curve cryptography algorithm. And sometimes that public key is used for implementing authentication, and the implementation of authentication is called as digital signature, which will be implemented with the help of DSS algorithm, that means digital signature standard algorithm. We may able to exchange the session key between two entities. For that, for creating the session keys at both ends, we should use an algorithm called Diffie-Hellman key exchange algorithm. So let us discuss the encryption and decryption process of public key application. So the first algorithm is RSA. The expansion of RSA is reversed Samir-Adleman algorithm, which was introduced at the year 1977. So RSA is the best known and widely used public key scheme application. And this RSA algorithm is purely based upon exponentiation, the exponentiation of prime moduli. So we should take the largest integer values for taking prime numbers for calculations. So you can be able to take maximum of 1024 bits as a prime numbers for implementing this RSA algorithm. So this is the algorithm. For implementing RSA algorithm, there is a need of two largest prime numbers, and those prime numbers are namely P and Q. And those two prime numbers are not equal. So that means that you should not take the same prime number for P and Q. So P and Q should be different prime numbers. Using that prime number, we should calculate the variable n. So n is equal to P into Q. And we should calculate Euler's pi function, that means pi of n. So pi of n is equal to P minus 1 into Q minus 1. Because n is the factors of P and Q. So by applying rule 3 of Euler's torsion function, pi of P is pi of P minus 1, pi of Q is pi of Q minus 1. That means Q minus 1. So by multiplying P minus 1 into Q minus 1, we can able to calculate pi of n. And then here we should select an integer value e. So the range of integer value should be greater than 1 and less than pi of n. Either they will give the public key, otherwise we should choose the public key e. So how can we calculate that e means this is the condition. That means if you take GCD of pi of n and e, that should be 1, which means that e and pi of n values are relatively prime to n. So that means that those two numbers are relatively prime. According to that pi of n value, we may able to choose e value from 2 to pi of n minus 1 value. Then after selecting public key e, we should calculate private key value d. So the calculation is d into e, that should be equivalent to 1 mod pi of n. Then from the e and n variable, we select public key as ku. So it is a pair of e and n. Public key is used for encryption purpose. Private key pair is kr. So kr is equal to d and n. This private key is used for decryption. Let me take m as a given message, means the encryption c is equal to m power e mod n. Then if you apply decryption with the given ciphertext c, the formula is c power d mod n is equal to m. So this is the steps that should be followed for implementing RSA algorithm for doing encryption and decryption process. So this is the encryption. So we are using exponentiation format. The formula is p power e mod n. Here p is taken as plain text. So this is the exponentiation calculation. So if you want to implement RSA algorithm, the number of bits for P and Q, minimum bits should be 512 bits and maximum you can use 1024 bits. That means that if you take a largest prime number and if you write its binary format, the binary number should be minimum 512 bits and maximum 1024 bits are possible. So this is the basic criteria for RSA algorithm. And in decryption also the same exponentiation is applied. That means C power D mod n. Here C is the ciphertext value. And this is the complexity operations. That means exponential calculation should be done at both ends. That means for encryption also exponentiation is implemented. At the decryption side also exponentiation is applied. So if Eve is an intruder, he will try to access the ciphertext value from allies, means he should do a logarithmic process for retrieving the correct plaintext from the given ciphertext value. So RSA normally using a modular exponentiation for both encryption and decryption side. So Eve is in need for calculating the plaintext value with applying square root of C to the power E mod n. So if Eve is in need of P value, he should do E to the E square of C mod n value. So that is the main complexity. So that only RSA is the most widely used public key encryption algorithm. So the previous steps are drawn here. So ally side n is the value which is the multiplication of two largest prime numbers, and we are doing exponentiation operation. So ciphertext C is equal to P power E mod n. So here E and n are public key values. So those values are passed to receiver side. So with the help of ciphertext, C power D mod n should be calculated. So Bob is in need of calculating a private key value. So he'll get a public key and n value from the user side. So select P and Q, n is equal to P into Q. And if Bob is in need of public key, he will try to calculate private key D. The formula is E into D mod pi of n, that should be equivalent to 1. So according to that, he will select the private key value for calculation of plaintext. So this is the encryption and decryption and key generation of RSA algorithm. So this is the generalized formula. So how the exponentiation can be done means n is the multiplications of two prime numbers. So mod n means we should apply Euler theorem. So if you take an Euler's theorem, the version 1 is a power pi of n mod n is equivalent to 1, where GCD of a and n are 1. So this is version 1. Version 2 of Euler's theorem is a to the power k into pi of n plus 1 mod n is equivalent to a. So in an RFA, we are doing n is equal to p into q calculation and pi of n is equal to p minus 1 into q minus 1, and we choose E and D from pi of n value. That means that we should select E. So we should calculate GCD of E comma pi of n, that should be equivalent to 1. And for calculating D value, E into D mod pi of n, that should be equivalent to 1. So if you take this formula from this one, this will be rewritten as E into D is equivalent to 1 plus k into pi of n. That means that the multiplication values is, if you get the remainder of E into D values, that remainder is in the format of k into pi of n notations. So if you take a decryption side, C power D is the calculation which was done at decryption side. So C means nothing but m power E. So this formula is applied for encryption for calculating E, C. So instead of C, I am writing it as m power E. So m power ED, here power value is ED. So instead of ED, I can able to write it as 1 plus k into pi of n. And this will be splitted as m power 1 into m power k into pi of n. So that k into pi of n can be rewritten as m to the power pi of n whole power k. So this a to the power pi of n mod n value is 1. So the same thing is applied here. M to the power pi of n mod n is also 1. So 1 to the power k is 1. So m power 1 is m. So m mod n is the resultant value. So if you use c power d mod n, we can able to retrieve m. So this is the proof for RSA decryption. Let us take an example. Here I am taking a 2-digit largest prime number. So P is equal to 17, Q is equal to 11, N is equal to P into Q. So the number is 187. Pi of N is equal to pi of P. So the value is 16. Pi of Q means 10. So 16 into 10, 160 is pi of N value. And we should calculate E. So the formula is GCD of E comma pi of N, that should be equivalent to 1. That means that you should select E value from 2 onwards. 2 and 160 is not 1 value. That means the GCD of 2 and 160 is not equal to 1. If we take E equal to 3, it's satisfied. So you take the value above 5. So if I am taking E equal to 7, 7 and 160 will give the GCD value as 1. So I am choosing the public key E is equal to 7. For calculating private key D into E mod pi of N is equivalent to 1. So I am taking D equal to 23. So you apply the formula 23 into 7, 161, 161 mod 160 is 1. So the public key pair is E and N. So 7 and 187. Private key is D and N. So the values are 23 and 187. Here they will give the message as M is equal to 88. So that value is less than N. That is one of the conditions for implementing the encryption purpose. So if you want to do encryption, the plain text value should be less than N. So the formula is C is equal to M to the power E mod N. So if you apply Euler's theorem concept, the answer is 11. For verifying that value, we should do decryption. So C power D, C value is 11, D is 23. So 11 to the power 23 mod 187 is plain text value 88. So this is the given plain text value. So in this way, we may able to implement an RSA algorithm implementation for doing problem. So I give 2 problems to you. So you should apply the same concepts for calculation of ciphertext and also verify the resultant value, whether the correct ciphertext value is retrieved from the given plaintext or not. Here P and Q are largest prime numbers. E should be the public key. Here M is the plaintext value. So instead of capital M, I mistakenly type in small m. So you just use capital M for calculations. And the same problem with different numbers are given. So you do the problem for implementation. I hope that RSA algorithm is best understood with this videos. Thank you.